Good morning. Welcome back to our database series, week 6. All right. Can you believe that we are already in week 6? I try to cover all the database related material in probably 8 or 9 weeks. Okay. So in the next 2 weeks or 3 weeks, I try to cover all the remaining database related material as well as all the stuff that related not directly to database, but it's actually very, very important that people actually using those tools like GitHubs and VirtualBox and all this stuff. Okay, so before we delve into the material for this week, let's actually just recap exactly what we did last week, week 5. Okay, so week 5 we basically try to we talk about why database design matters, because the design of the database is really, really crucial, right? Database isn't just about querying, um, you know, interacting with the database through the 4 basic operation, like you retrieve the data from the database and you delete, you update. Database is about creating and design a very good um, system, database system, effectively. Okay, so we first look at the database design by looking at the database has already been well built, already been designed, which is the book store that we have in our database project description. Okay, so this is what we do. We basically look at all this table already been designed for us. When the table well designed, it say it's been well normalized. Okay, we talk about that stuff, and then we talk about that. You have to create it, a schema for your database, right? And then after that, you create it, you populate data into those tables structure that you just created it, okay? Remember that before we doing this, we basically just install a sample database, the Sakila database, right? And we unzip the folder, we have two files, a schema and the data, right? So basically, and then the next step that we do, we basically looking at our database that has already been designed, okay? And then we basically try to create it, the schema, just like how the sample database as Aquila show us. And then after that, we basically populate data into each of those 5 tables, okay? And now, since the database design is so crucial, I'm gonna devote it one more week to talk about the database design, okay? Let's say that, you know what, we first looking at how the system already been designed and take a look at, the well-built, well-designed system. And then we learn how to create it, everything from scratch, right? It's kind of like, you know, when you first learn how to do things, they're going to show you, okay, this is the specific method you use to solve this given problem, right? And then the next higher level, they basically just give you the given problem. Given the problem, you know, you you just you just you're free to solve this problem any way you want, as long as the problem gets solved, right? And the next level up, you basically have to start it from scratch. You have to identify what the problem is. That's pretty much just like in the real world scenario, the real life scenario. You have to identify the issue, the problem yourself, and then be able to solve that problem whichever way that works for you, right? Before basic level, they show you that we have this problem. This is a specific method, specific format. You have to solve the problem. Next one, you have to sort of like solve problem whichever you want. Next one, you have to identify what the issues are, okay? In real life, you have to create your own database from scratch. And how do we do that, right? So how do we design a database that is well designed, is well built, right? And that's what the normalization of the database is for, right? When we talk about database design, we often hear people say normalization. Basically, what is normalization? Okay, so I have these things here. What is in database design, people talk about the normalization. What is the normalization, right? And what is normalization for, right? So we have to ask all these two questions. What is normalization? Normalization is kind of like you organize it. If you look up the definition of database normalization, they will say that normalization is a way of organizing data into a structure in such a way that you'll be able to retrieve the information efficiently, right? But in the way, it's sort of like you organizing your clothes in your closet, right? It's kind of like it's kind of like disorganized, places, stuff is all over the places, and you're gonna pull all of those clothes out, all of your clothes out from the closet, and you basically sort them out. You put them into category. You say that you're gonna divide them into indoor clothes, sleepwear, underwear, socks, from the outdoor clothes, a jacket, and then you basically just, subdivide the outdoor clothes. Maybe you're gonna have, as you subdivide them into a bottom wear and then top wear. A bottom wear, maybe you have a jean, or you have a pant, a slack, right? And then within the shirt, your your top wear, you're gonna divide it into sort of like t-shirt and a shirt. Within t-shirt, you subdivide it into, is that a long sleeve or is that a short sleeve, right? And then you specify specific location for each category of those clothes. Let's say that all of the jacket going to be on the top left corner of the closet, right? And all of your underwear and socks going to go to the bottom left of the corner, right? And you specify only one location for one category of clothes, right? So by the time you organize your closet, you know for sure that if you're looking for a jacket, you're going to go to the top left corner. You're looking for socks, you're going to go to the bottom left corner. You're not going to look for socks or jacket in the on the bottom right. Okay, so that's exactly what the normalization is. They basically organize data, organize item in such a way that they do not have. What is the normalization for? So we look into why do we need our normalization. We need normalization in order for us to accomplish 3 goals, right? The first one, reduce data redundancy. Another word is you don't have the same, data at the various location. You're not going to find a jacket, over here at the bottom, on top left, and you're not going to find a jacket in the bottom right. Okay, it's only top left in the designated area, designated place in the closet where you store them. And then, that's what I mean. You don't have the same category of clothes. You don't have the same data at the various location. Improve data integrity. It's kind of like integrity, accuracy, data accuracy. If you have data at the multiple location, then you update a data in one location. It will update across the entire database, right? Okay, and then the third goal of normalizing your database design is to prevent any anomalies. Anomaly is sort of like side effects, when it comes to insertion, to updating, or to deletion, which means that, you cannot insert data without inserting another data, right? And if you have the same data at multiple location, various location, you update one location, it does not update, all places. And then the side effect of deletion is that if you delete one piece of information, delete the whole thing. Okay, so those are the 3 goals of database design normalization, and why do we need normalization when it comes to designing our database. And one of the way for us to achieve a good design, a good well-normalized database, they're using a series of forms. It's called the first normal form, the second normal form, and third normal form. Basically, this is kind of like a set of rules and guidelines to help you achieve the optimal level of normalization. That's all it is. It's help you to sort of like be able to create the most efficient design. Okay. Um, it's the first form, the second normal form, and third normal form. These are sort of like like the construction worker use sort of like ruler to make sure that this thing is perpendicular, right? So they have a ruler to make sure that it is 90 degree, to make sure that, oh, this thing perpendicular to these things, right? Normal form, second normal form, the third normal form is sort of like a ruler, a measurement types of tools that the construction worker use, okay? And remember, why do we need such a very good, well-designed, well-normalized database? Because in order for us to generate any kind of reports, we have to rely on the database. Imagine the scenario. Let's say that the Department of Commerce in the United States, they just want to know the top, 5 countries that actually import into the United States from the entire world, from the world. What are the top 5 countries that actually have the imports into the United States, and what are those products, right? And then another real life scenario. Let's say that the Department of Homeland Security, the DHS, right? That's the abbreviation for Homeland Security, not the Department of Homeland Services. Still same abbreviation, DHS, but this is the Department of Homeland Security, not the Department of Homeland Services, right? Let's say the Department of Homeland Security want to ask a question. They say that, list me of all people currently living in the United States, whether they U.S. citizen or they non-U.S. citizen, and give me the list of all those people currently staying in the United States that have traveled to and from specific list of countries, more than 10 times in the last 6 months, right? So how do you get all this generated report? The reason that these report are generated, and it's possible to have this generate report because of the underlying structure that they have, and that is the database. And when we need to have the database, we need to have a good database design, right? So I don't know how big is, the database that the Department of Commerce in the United States use, or any department that United States use, but they be able to sort of like go into, this underlying data structure called database and be able to ask any question, and they be able to generate all kind of report, okay? And they want to take a look at, let's say, a specific person to see how, what is their name, what is their social background, what their economic background, what is their educational background, and to see how financially responsible this person is. They basically just have to rely on, the credit report. Just take a look at, how financially responsible the person is by looking at their credit report. And all this credit bureau, they use database to store all this stuff, how you make a payment and all this stuff, okay? So having a database is important, and having a good database design is even more important, okay? So that's why we have to use all this tool, all these metrics, right? To sort of like guidelines so that we can actually get a well design. And when you design a database, you are aiming for the third normal form, okay? Let's say, for example, like this one right here, the Department of Commerce. They want to know exactly what is the top 5, products, fruit that has been imported. They're going to take a look at it, see how, this is the list of 10, fruit, right? And they want to see how Apple is doing, right? They say that Apple is, right? They want to see how Grab is doing. Well, Grab is actually ranked number 3, right? In this list. They want to see exactly how specific in each, doing. How oranges is doing. Well, it's actually ranked number 2, 4, 6, right? And what is the number 1, imported fruit? And let's take a look at it. It's yeah, Oh, that's clever, right? So in order for them to generate this kind of report, they have to rely on data from the underlying data structure, which is a database, okay? So having a good database, a well-built, well-designed database is critical, okay? So let's talk about all of this stuff. The first normal form, right? The first normal form, um, you eliminate repeating groups or ensure all columns contain atomic value, assign a primary key, right? In order for us to sort of like understand this process of normalizing the database using the first and the second and third normal form, let's actually take a look at a one big table that is unnormalized, right? That's exactly how we design a database. You know, you're gonna design a database for yourself or for a small business, right? For an organization. You know, you take time to really understand the business requirement. You know, like I said last week, you know, let's say that given 2 years that you have to develop, you know, if you've been given 18 months, a year and a half to 2 years to sort of like develop a tool, automated tool, some sort of like software, you know, module, you know, I would say that the first 6 months, you know, 8 months of that, you know, 18 months, 2 years, you know, you basically just try to come in and talk to the business to see exactly how, you know, what is the business requirement, you know, what the stuff that they normally do. In order for you to automate anything, to those things automatically, you have to see how the tasks are being done manually first, and you have to understand every task that done manually in very details, in every step, right? In order to automate those things. Okay, so now let's take a look at it, and then let's say that you gather all this information, and let's say we have one big table, right? Let's say we have one big table that is probably not normalized, okay? You know, one big table that's not normalized is kind of like, you know, now it's unnormalized. It's not well designed, right? You just recorded all the information. You say that to run this kind of business, you know, like, for example, let's take a look at the most profitable business in the world. Education, school, university provide education. It's a service oriented, right? That's why a lot of top country in the world, all the advanced country in the world, they are service oriented. They providing services, right? Those are the most profitable business types of business. Okay, so let's say that we record all this. You know what? This is kind of like unnormalized. One big table, you get all the information, okay? And then how do we normalize, right? We normalize by breaking all this into a smaller tables, right? And first of all, you need to, you aiming for the third normal form. But in order for you to get to the third one, you need to get to the second one. In order for you to get to the second one, you first need to get your database into the first form, okay? So what is the first form requiring? What is the rule? They say the first rule, the rule for the first normal form, eliminate repeating groups or ensure all columns contain atomic values, assign a primary key, right? To achieve the first normal form, we need to ensure each row uniquely identify all the item, okay? Now, let's take a look at this unnormalized tables, one big tables. Let's make this easier. Let's just free the top pen. Okay. Okay, you have make this one a little. Yeah. Right. I don't know. I just want to make it visible. That's it. Right. Just make this one. Right. So, okay. So let's try to break this one down into, we have to sort of like get off database into the first form. No, eliminate the repeating groups, okay? So basically, this is all the repeating groups. You see that Alex Smith, this one is repeating. You have this record is repeating, right? And you have Charles Lee, this repeating. So that is a good candidate to sort of like separate them into its own table. So basically, you're gonna have this. Move them into sort of like its own table, right? Course, ID, CS 101, Introduction to CS, and you actually have another one here, right? Calculus 1, you know. So because of the repeating item, you actually have, so you have to sort of like move them over here to its own table. Okay, and then you have, you see all this one, you see this one right here, CS 101, Intro to CS, you know, and then you see another CS 101, that's repeated. So you try to sort of like move it into another table, and let's say you have instructor ID, move them over here. Right, and you have the department. And then enrollment basically is just enrollment is for the student, right? So it has to do with a courses that the student, specific student enrolled, and then the grade for that particular course. So that is basically, you're gonna have the enrollment grade over here, right? And then of course, you know, the instructor, the name, right? Instructor, the name, right? And then the student. And then the course ID, right? Right? So now, we basically, and then all this one right here, you just have to delete this one, because you have, there's no repeating information. You see that? You have two rows, that's exactly the same, that's repeated information. Okay, so now, last one. Okay, so this table right here is actually meet the first form of normalization. No repeated information. There is no two rows that are exactly the same. Okay, same here. With the course ID, you see this one right here, and you see this one right here. That's basically the same stuff, right? So you get rid of that. That's it, right? And then you move. Okay, so take a look at all this one right here. All the rows are unique. You know, you don't have any repeating row. Okay, so which is good. Ready, right? The instructor ID. You see that? You have, you delete this one right here. Right, and then 103 right here. You have this repeating. All right, so basically, so on and so forth. This one right here, or this table is actually already, we actually break them into these smaller tables, right? Okay, 1, 2, 3, 4, 5, right? That's the first form of normalization, right? To eliminate all repeating groups and ensure all column contain atomic values aside the primary key. Let's say that student ID a primary key, so we make it, we just highlight them. Course ID is a primary key, right? Department ID is a primary key. And then the student ID and the course ID, this is the primary key, but the primary key are composite key when two columns or more combine together to uniquely identify a record. So the primary key in this table right here, it basically is a composite key, right? So you have two, right? Now, once we already get the first form established for our database design, you take a look at the second. What else? Now we try to move ourselves into the second normal form. Must be in one normal form. Okay, we got the first normal form already. No partial dependency. No partial dependency, right? All non-key attribute must be fully functionally dependent on the entire primary key. Let's say that we have the instructor ID, right? Take a look at this enrollment table right here. The student ID, course ID, enrollment, day, grade. You know, this is kind of like the grade for each courses for specific students. You have the instructor. The primary key for this table is the composite key, like I said. Is actually have the student ID and the course ID, right? Okay, this is the primary key, the course ID and the student ID. But remember that the instructor ID does not depend on the student. The instructor is associated with the course they teach. It's not associated with the student ID. So what that means is that which means that this table right here violated the second normal form. No partial dependency. All the key must be fully functionally dependent on the entire primary key. Our entire primary key in this table is student ID and course ID, but the instructor ID is not associated with the student. It does associate with the course ID. So this is actually violated, you know, the second form. So what we try to do, the instructor is determined by the course they teach, you know, like the department assign specific course for a specific instructor. So you have to sort of like fix that by removing this one right here, the instructor ID. Is associated with the course. So you have to remove these things right here. Right? And then you have to sort of like take a look at, change the course table. So this is going to be our newly revised course table, right? Because you know what, now everything depends on the primary key, right? The enrollment, basically, the student ID, the enrollment depends on the student and the course ID. And the grade that the student gets for each course depends on the student ID and the course. So this is good. All the non-key, these are the non-key, then the one that has not been highlighted is actually fully dependent on the entire primary key, which is the two column right here, student ID and course ID, okay? And this one right here, course name depend entirely on course ID, credit. The instructor depends on the course ID. You know, the department assign specific professor to teach certain class. Okay, so now all of our table is actually, this one right here is actually fulfill our second normal form, right? This right here is fulfill our second normal form. It's already fulfilled, you know? We have no partial dependency. And what I say at the beginning, we try to aim for the third normal form when we normalize, when we design our database. Okay, now let's move on and take a look at what is the rule for the third normal form. Because if our database been normalized and it's achieved the third normal form, which means that our design is pretty good. That's one way to test that. Okay, so now we move on to the third normal form. Must be in the second normal form. All of this table already in the second normal form. No transitive dependency, right? No transitive dependency. No non-key attribute should depend on another non-key attribute. In other words, attribute should depend directly on the primary key, right? Directly on the primary key, okay? So remember that the rule for the second normal form that, you should depend entirely on the primary key. Let's say that if you have the composite key, the primary key is a composite key, you have more than 2 columns, then all of this non-key attributes should fully depend on the entire primary key, right? The rule for the third normal form that there's no transitive dependency, which means that when you take a look at the course, all right, this one right here is going to be good. Right. Wait. The student is good, right? This is actually very good, right? We check the rule of the third normal form for this table. This is good. We don't have any, all of this one directly depends on the primary key, which is good. This one right here directly relate on the primary key with this instructor ID, which is good. Department ID, which is good. The student ID, course ID. The non-key attribute, enrollment, grade in this case, directly depends on the primary key, which is good. Okay, now, this table right here, the instructor name, which is the non-key attribute, it depends on the instructor ID, but it does not depend on the course ID. See what I'm saying? So in a way, it basically, the instructor ID is a non-key attribute. The instructor name is not determined by the course ID. It's actually determined by the instructor ID. So it's kind of like your name is determined by your social security number. It's not determined by the school or university you attended or any courses you take, right? In order for people to know your name, they just look it up your social security number. The instructor ID is kind of like that, It's a primary key for the instructor table. So that this column right here, this non-key attribute is actually depend on the instructor ID, not the course ID. But the instructor ID, it depend on the course ID in this table, enrollment table, in this course table. So that's why you have to remove that one, because there is a case of transitive dependency. And remember, the rule for the third normal form is no transitive dependency, right? Because this one right here depend on this one, and this one depend on this one, and this two is a non-key attributes. So that's why you have to remove the instructor name and move it into, you have to remove that. Right? Just delete that. Now this one right here, we don't have any non-key attribute. We don't have any column that is not key. That's actually not directly related to the primary key, so which is good. Right? And then we're missing the department ID for this one here. Right? Because you know what? The department ID, the instructor ID, the department ID, right? Yeah, actually, no. The department ID is actually determined by the instructor ID. So you have to sort of like get this one right here. That's it, right? Because you know what, this one right here, all of this table for our database at this stage is already fulfill our third normal form. Check the rule, check all of this table against the rule of our third normal form to make sure that none key attribute is directly related on a primary key, right? The instructor, the department ID, the department ID depend on the instructor ID, the instructor, specific instructor teaching specific course. Let's say physics, chemistry, they actually have their offices in the department ID, right? That's the department ID. Is directly depends on the instructor ID. So this is good. So this is our table right here. From the big table that we have right here, right? That is anomalized. We actually broken down into 5 smaller table. 1, 2, 3, 4, 5. Okay, and that is probably the database design for this database has already been normalized, and all of this table is achieving to the third normal form. And how do we know for sure it's achieved our third normal form? You have to check, each of these 5 table against the rule for the third normal form. Okay, that's it. That's the goal of our today's presentation. We just want to make sure that we design a good database from scratch, and by observing how the business conducting that business transaction on a regular basis, understand the business requirement, understand the business rule, and that's how we capture all this information. Initially from a big table, you get all the information, and it's unnormalized. It's not well designed yet, and then after that you try to break into a smaller table by using all these guidelines: first normal form, second normal form, and third normal form in the process of normalizing our database. Okay, and that's how we got it. Okay, that's the end of our presentation for this week, and try to sort of like imagine a real life scenario, in your real life, or anything that you want to build a database for. Try to capture all this information, like information gathering, and then try to figure out what would be a good design for this types of database that we need to store all the data. Remember, I'm telling you, for all this, real life, real world scenario, in order for people to generate all this kind of report, what are the top country that export into United States? What are the top 10 countries that United States export their goods and services to in the world? They relied on the underlying data structure called database. And in order for us to have a database, we have to have a database design very good in the first place. It's kind of like before you populate data into a table, it's good that you have all this table neatly organized, right? It's like, before you move people into a new place, a new city, a new house, make sure that the house is well built first. And then you probably have all this room divided, and then you can move people into it, and they can place furniture. You can move people into the city, make sure that city is well designed first, okay? That's it. Is remember, database is a collection of tables, right? So database table, right? And all these tables are linked together using a mechanism known as primary key and foreign key. That's why it's called relational database. All these tables are related, are linked together. So that's why it's database, table, links, relational database, So I hope that you probably get a good sense of how to design a database from scratch by going through this process of normalization. Even though this is not a lot of information, but it is a fundamental, critical information component that you use time to understand the concept, right? So it's not like a lot of information to understand all of them, but it's a good it's a good information that take you quite some time to really understand thoroughly. So take time to understand all this stuff. I not be able to sort of like, but at least I be able to present you all the area, the right area that you should have your focus on when it comes to designing database from scratch. Okay. Thank you so much, and I'm looking forward to see you, next week, week 7. Okay. So try to create it, design some database from scratch. Okay, by gathering information about the business or anything you want to do, and try to see how do you store all this data. First of all, try to store all of them in one big table that is anomalized, and then after that, break them into a smaller tables, and make sure all of this table actually meet the rule for each of these form as you go through the normalization process. Thank you so much for your time, and I'm looking forward to see you next week. Bye.